Hello, Peter here. In the last episode we implemented ambient lighting. It also tested the SDL framework. So now we can go on with something way more cool, namely our first real dynamic lighting feature, directional lighting. First we open the SDL level data actor. And we need to do something here before the set halt tick. Break the link and make some space. We don't know how much. This is enough. Get all actors of class. What we want is to get all the directional lights. Now we're going to assume there is only one there. So we're going to use an for each loop. And in the loop body we're going to set a variable. So let's promote this one to a variable. Set it. And the name of that one we can set to Directional Light. And now we can hook up the set again. And that is what we needed to do in the level data actor. Compile this, and we save this. And close the window. So now open the SDL component. And this is what we did last time. First we're going to create 3 properties in the SDL category. So let's add those. First one is receive directional light. The second one is directional light trace length. This is a float. And the third one is directional light multiplier. Now all of them need to be editable, and we need to put them in the SDL category. Like so. It will become clear exactly what they are doing, because now we need to create the function SetDirectionalLight. So let's create it. SetDirectionalLight. So the first thing we need to do is to see if our directional light is valid. But first we have to get it, and we get it from the SDL level data and then directional light. Get directional light here. Now either it's the last one from the for each loop, or if there were no lights it would be invalid. So that is why we need to test it and say is valid. And if it is not valid, we can't do anything, and we do a return node. Now we want to have one output in our return node, and we call that outLit. It is a boolean, and it will say if the object is lit by the directional light or not. Well, in this case we couldn't do anything, so it's set to false. We want to have the light component of the directional light if it is valid. So let's say light component, get light component here. And we want to promote that one to a variable, a local variable in this case. like this. And we will call this new variable simply light component. Now we need to get our directional light trace length, because we're going to make a decision based if that one is greater than 0. We can leave this to 0. If that is so, and our flag here, receive directional light, let's get that one out too. This flag basically tells us if we want to receive directional light at all. And these two combined and will give us the value, the condition for the decision that we're going to make here, and that is a branch based on this condition, that if both are true, we are going to use a line trace to see if the directional light is blocked. If the directional light trace length is 0, we are not going to bother with traces, and then we just go on from the false. So let's do that one first. If receive directional light is set, and we are not going to use a trace, we are sure that the output of this function is going to be lit. So we are going to set the internal lit, and that is a local variable. So let's promote that to a variable, and let's call it immediately internal lit. And let's set this one. Now we do that only in the case of false. Now from here we are going to set the vector parameter values in our dynamic material. So let's get out the dynamic material and set vector parameter value. Now the first one, we're going to set DL color, which was dynamic light color, and we can also set a vector parameter value, the second one, and that one is the DL normal, DL underscore normal. And we're going to do that straight from the set. We get back to the values in a moment. After this, we are returning from the function, and the value that we're going to put in out lit is going to be our internal lit. So get that one and hook it up. So now let's look at our values here. Let's start with the normal. And to set the normal, we need the light component. And we need to get its rotation. And a directional light shines in the x vector direction, so we can set get rotation x vector. And this already has magnitude 1, so it is normalized. So this is the one that we need. But now remember that in our material function we remove the multiply by -1 to reverse the direction, so we need to do that here now. So we multiply this one with -1, and then we have our normal. And we can hook that one up immediately here in value. It will create a note because this will be converted to linear color. What we also need from the light component is the color, the light color. And that is not really the one that I need here. I want this one, because that one already is in the right linear color format. Let's draw slightly back. We need intensity. Get intensity, and we also had our own directional light multiplier here, and let's get that as well, because that will give us the possibility to modify the intensity per object. So the intensity we're going to multiply with the directional light multiplier. Now let's have a look at directional light multiplier, and we see we didn't have a default value for that one. So let's compile this and give this a default value of 1. So if we do nothing, it will just be the intensity that was defined for the directional light. Now we need to add a pin, because we want to incorporate our internal lit here. This is a boolean that says right now if the object is lit or not. So based from this one, I want to select a float, and if it is lit, we're going to select 1, otherwise B, which is 0. And we want this to be multiplied here with the whole thing. So what happens, we just calculate intensity and our and everything, but if we are not lit, it should still come out to 0. We shouldn't have any effects if we weren't lit. Right, so then we take our color here and multiply our linear color with a float. Now this now gives us the value that we need to put in the DL color. Now let's have a look at the other end of the decision. When we're going to use our trace length, when trace length is greater than 0, then we're going to drag out here and do a line trace for object. Now we need to supply the object types, and that is an array, so make array. And let's see what kind of object types we want. World static seems good. World dynamic is good. We add another pin and take destructible. Now you can always add things here, like if you want to have a vehicle or something blocking the light, you can all do that. So but I keep it at these 3 now: world static, dynamic, and destructible. Now we need to configure the trace itself. First we need to start. So what is the start of our trace? That is get world location of our component here. So let's put that one in there. Then to get the end of the trace, we need to get our light component again. Get the light component, and again get the world rotation for it, and they get rotation x factor, because that is the direction in which it shines. Now we need to get the directional light trace length and multiply it by -1. Because we want to trace from our component, from the object, towards the light. So we make this with a negative sign, and then we multiply the vector with this float. Because this one was normalized, so by multiplying it with the directional light trace length in the opposite direction, we have the right length. So the only thing we need to do is to get our start and add the two vectors. And this will be the end point of our trace. Let's move it slightly, this side, to make it more clear. Okay, now straight from the trace we need to set our internal lit. So, and that is based on if we hit something or not. So the return value here is interesting. We do a set of internal lit with not the value, the return value, because this one will be false if nothing is hit. So then we have internal lit. And now I can move this one slightly out of the way so that we can connect up this. And that is our function. Cool. Compile it and save it. Close this window. We shouldn't really close it yet because we need to call the function. This was just the function implementation. We need to go to our event graph now, because here we still need to make the call, and that is simply set directional light like this, and now we can compile and save it and close the window. Now let's see if it works. Let's have a look at our sphere. Let's drag this out a bit and click our SDL component. We see we have our new properties here. We also see that maybe we should have set receive directional light default checked, because that's a very normal situation, of course. Let's leave the trace length to 0, multiply to 1 for now. Let's disable the ambient light and let's see what happens. We have a very nice directional light on it. Cool, that works. Now let's introduce the trace. Let's put 2000 there, that's about 20 meters. And before we play it, let's make it more visible by draw a debug. For 1 frame, compile, save. And let's see that one. Now we have a nice line. And now if something is going to be in the way for the light, it will go off, and it does. And when it is, see, now the light was there again, and now this wall is in the way. So that is natural behavior for a directional light. Good. Let's see if our intensity does anything. Let's make that 2. Yeah, that makes it more light. Hard to see maybe. Make it 10. Play. Yeah, you see, now you see it really good. Good. Okay, let's fix those default values real quick. We can remove the debug. And what do we want? We want in the event graph, we want to have receive directional, we want that be on by default. The trace length we can set to 2000. That seems quite a good value for me. And compile and save. One thing we haven't tested yet, and that is to combine both the ambient light with the directional light. Let's put that back to 1, which is much more normal. Have a fairly low ambient light intensity, and we will see if we play this that now both of them are at work. See, it's no longer completely black in the shadow. And if we get this ball in here, you will see the ambient light is still working. So that is our directional light done. Awesome. Well, in the next episode we will have a look at point lights. So see you then. Bye bye. Hello, Peter here again. Just wanted to say thanks for watching this video. Please let me know what you thought of it in the comments. Below there are links to other episodes in the series, and don't forget to subscribe so you are the first to know when the next episode is up. Thanks again for watching, and see you in the next video. Bye!